I want to talk about this word logic for a while because that's going to be basically what the video is about. Logic is, by definition, the study of reasoning, but it's a lot more, and you need to get a bit more in-depth with this 5-letter word if you want to do good on examinations. So let's start with really basic stuff. So we have this word here. It's called a mathematical sentence. And a mathematical sentence is basically anything that you can determine explicitly whether it is true or false. An example of a mathematical sentence is that 2 plus 5 equals 9. It doesn't matter if it's true or false. The only thing that I'm asking you right now is if you can determine if it's true or false, and in this case 2 plus 5 does not equal 9, so this is false. But if you can assign a truth value to this statement, then it becomes a mathematical sentence. Another sentence, it doesn't have to be just numbers and symbols. It can be today it is Sunday. You can determine if this is true or false. Well, in my case, today it's Saturday, so it is, again, false. But if it was Sunday, then I would say it was true. And if I can say if it's true or false, then it's a mathematical sentence. And the opposite of this is called a phrase, and it's just part of a sentence. So if I just put, is Sunday, can I determine if it's true or false? I sure can't. What does that even mean? Another example is if I just put 5 plus 2. I have no idea what that means. I don't know if it's true or false. It's just a phrase. It's just part of a sentence. And then you have open sentences, which are kind of like mathematical sentences, except you still can't prove if it's true or false because it has a variable. So one example is 5x equals 15. Okay, we know that x equals 3, but how do we know if it's true or false? I have no idea. If x is 2, then it's false. If x is 3, it's true. I don't know if I can explicitly determine a truth value to this because it has a variable. So we can't do anything to it. But if we put in a number from a domain, and a domain is the set of numbers that can just replace a variable. So in this case, a domain can be basically any I guess, real number here, right? 5, or just any number in general. A domain is just, for this sentence, a domain can go on forever. And then there's going to be a solution set, which is part of the domain of numbers. But in this case, it's just going to give you all the possible answers to make that open sentence true. So our example, 5x equals 15, the solution set for that would be 3. Similarly, if I said x squared equals 4, the solution set is either 2 or -2. Now we get into stuff that's a little bit more fun. The first thing that you need to know is called a negation. And this symbol is primarily symbolized as a kind of wavy tilde thing in front of a letter such as P or Q. And this can be read out as not P or not Q or whatever letter you are using, and it just produces the opposite truth value of P. So if P was true and I said what is not P, then it would be false. And then you have compound statements that I'm going to cover. I'm just going to do the first two right now, which is a conjunction and a disjunction. The conjunction is a compound sentence using the word and it's this kind of upside down V caret shape symbol. And if I wanted to put it in notation, P and Q, and that's how you would read it. And for this one, it'd be P or Q, and it's an actual V, and it's a disjunction. And there are certain statements, given statements, for any value of P and Q. So let's make something called a truth table. So this is my expertly drawn truth table, and I'm just going to fill in some values here. Let's say that PQ can either be both true. P and Q could be true and then false, or false and then true, or they can be both false. And for a conjunction here, this is the conjunction, P and Q. P and Q is only true if both values are true. So for the rest of these, P and Q is going to be false. On the flip side, P or Q is only false if both values are false. So only this value will be false, and then the other values will be true. And it kind of makes sense if you just think about it for a while. And then you have conditionals, which is drawn by an arrow sign that looks like that. And it reads out as P implies Q, or if P then Q. And conditional is only going to be false if the P value, the first value, is true and the Q value is false. So if I were to make a mini truth table here, P and then Q, and boop, 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 boop. P implies Q is only going to be false if P is true and Q is false. And that kind of makes sense if you think about it again. Try taking it into sentence form. Say that if you do good, say I told you, if you do good on your test, I will bring you to the movies. Okay, let's look at the truth values for all of them. So P would be you do well on your test, and Q would be I take you to the movies. And if what actually occurs is you do good on your test, okay, P is true, and I take you to the movies, Q, that's also true. So P implies Q, that's true. And it works for all others too, except for P is true, Q is false. Because let's say you did well on your test, but I lied and I didn't bring you to the movies. Then what I promised you is false, so that conditional is false. And oftentimes we call this P, this if statement, we call it the hypothesis. And it usually follows the word if. And it's also called the premise or the antecedent, and this Q is commonly referred to as the conclusion. And it follows the word then, and you can also call it a consequent. Now there's different operations that we can do with these conditionals, and there are 4. So we have the default conditional, and then we have the inverse, and then we have the converse, and then we have the contrapositive of a conditional. And I'm just going to tell you what each of these looks like. So if the conditional is P implies Q, the inverse is going to be the negation of both P and Q, so it's going to look like that. The converse is going to be the flip of both, so instead of P implies Q, it's going to be Q implies P. And the contrapositive is the combination of both, which is not Q implying not P. Now, these values are logically equivalent, and these values are logically equivalent. And logically equivalent means that they have the same truth value. The last thing you need to know is a biconditional, and it's a double arrow going both ways, and it's read as P is this if and only if Q is this. And if P and Q are the same value, if they're both true or they're both false, then the biconditional will be true, but if they're different values, the biconditional will be false. So P, Q, they will be true if they're both true or false, but if they're different truth values, the biconditional will be false. And it helps really to memorize your truth tables, even though this is more like a invisible grid than a table. You should memorize them and know your rules, and it's pretty helpful when you do.